Severe weather. It's a common occurrence here in South Mississippi. And the first thing we look at when storm strikes is radar. You can see it on TV, on the internet, and even your phone. But for years, the radar coverage was subpar. And while the average person never saw an issue, to meteorologists, it was a thorn in our side. So what was the problem with the radar? Well, it was scanning too high into the storm and not scanning the parts that we needed to see closer to the ground. Meteorologist Eric Carpenter with the National Weather Service explains.
Over time, there's definitely been a lot of discussion about having better radar coverage. And one of the easiest ways to do that, other than actually building radars or more radars, is to take the current radars and lower the radar beam down just slightly.
And while this is just as easy as pressing a button, we are talking about the federal government, of course, which means bureaucracy, red tape, and a 71-page environmental and health study. After months and months of waiting, the National Weather Service in Jackson was finally allowed to lower their radar beam. So we're here at the National Weather Service Doppler radar in Brandon. It's located inside that white ball on top of the tower. Inside is a giant dish. Now what they did was they dropped that dish by 0.2 degrees. And while that sounds like a very small change, it has made a drastic difference for the Pine Belt.
So in a severe thunderstorm with tornadoes, there's a lot of critical processes that go on in those lowest few thousand feet. Just missing a few hundred feet of the storm at the lowest levels can make a big difference in what you're seeing as far as the rotation.
And being able to see a few thousand feet lower can mean the difference of minutes when it comes to issuing warnings. So how can a change that small impact us in Hattiesburg? Well, let's go on a trip and I'll show you. So we're back here in the Pine Belt now, and the reason this is so beneficial to us is because of trig. You know, that very boring math back in high school. So what happens, the further away you get from the radar, the higher the beam is in the air. By the time the beam got to Hattiesburg and Laurel, it was 7,000 feet in the air. With the new scheme, it's only 4,000 feet in the air, a much better improvement.
So with that extra information, we have more confidence with our warnings. We can put more detail. We're confident that a particular tornado is going to be worse. To have that kind of information that gives us that extra confidence allows us to put that kind of information into the warnings, and people will take action more quickly. They're more apt to take action when they have that kind of information in the warnings, and it keeps them safer as a result.
And lead time is the name of the game, because when severe weather strikes, an extra minute or two can literally mean the difference between life and death. For the First Alert Weather Team, I'm meteorologist Patrick Bigbie.